Hi and Assalamualaikum. In this video, me and my group members will explain about light properties which contains of reflection, refraction and shadowing. I am Sofea Nabila and introducing my group members. KHENG, Siti Sarah, Muhammad HAIQAL and RABBIATUL ADDAWIYYAH. Firstly, I am going to give a quick brief on what is light. So, light is often known as visible light. It also defined as electromagnetic radiation with wavelength range between 380 and 750 nanometer. It is also visible to human eye. Light allows us to see our surroundings and experience them. Sunlight is a simple light source. Next one is properties of light. So, light travel as wave and it produces amplitude, wavelength, and frequency. It also travels in straight lines with a speed of 3.0 times 10 power of 8 millisecond in a vacuum. So our main purpose of this video is to actually further explain on these three properties, which are reflected, refracted, and how light causes shadowing.
Okay, let's continue with reflection. What is reflection? Reflection is the abrupt change in the direction of propagation of a wave that strike the boundary between different medium. If you look the example here, there is a wave that strike to the mirror from the air. It will produce a new wave from the mirror that have the same angle with the incident ray. So what is actually the incident ray? Let's take a look at a law of reflection. Law of reflection states that the angle of reflected ray must equal to the angle of the incident ray. Incident ray is where the light is coming from, where the reflected ray is when the light strikes away from the reflected medium. There are two types of reflection, which is on reflection on different surface and reflection on rock surface. On smooth surface, the incident ray will hit a surface that is smooth and shiny, so it will follow the law of reflection, which states that the angle of incident ray will equal to the angle of reflection. Another different scenario is when the light hit a rock surface. It will scatter away because the light hit a surface that is not flat, not smooth, and not shiny. As we know, optical fiber use light to transmit data, which is laser. So, the light will enter the center of the core that have high refractive index than the cladding. In order the light to reflect back to the core, the incident ray angle must be bigger than the critical angles, or else the light will absorb by the cladding and will go away from the internal core. This is what we call loss in the fiber.
Next one is a refraction. What is a refraction? In physics, refraction is the direction of the way it passes from one medium to another medium of different refractive indices. At the below animation, we can see that when the light is traveled from one medium to another medium, the direction of the light is bent at another medium. In the daily life, we can simply notice the reflection when we put the things into the water. We can see that the shape of the thing is bent in the water. Next one is the Snell law. The Snell law states the relationship between the angle of incident and reflection and the indices of the reflection of the two mediums. Snell law applies to the reflection of light in any situation regardless of what the two mediums are. The below is the formula of the Snell law. Next is the higher refractive index and the lower refractive index. When light enters a more denser medium, it's bent more toward the normalized. As the picture at the left side, we can see that when the light travels from the less denser medium to the more denser medium, the light is bent toward the normalized. However, as the picture on the right side, we can see that when the light travels from more denser medium to the less denser medium, the light is bent far away from the normalized. In fiber optics, it works on the principle of the total internal reflections with two conditions. First is ray must travel from higher denser medium to less denser mediums. The second one is the incidence angle is to greater than the critical angle because to make sure all the lights is undergo reflection.
Moving forward, what is shadowing? If the light cannot get through an object, the surface on the other side of that object will have less light reaching it, hence resulting into the absence of light or shadows. We must remember the shape of the shadows are determined by the shape of the objects. However, shadow is not a reflection, even though it is often the same shape as the object. What is the relationship between the object's position, light source, and resulting shadows? An object's shadows is determined by the object's shapes. However, it can also change. These changes are caused by the position of light source. For instance, the distance between light source and object. The shorter and longer the object to the light source, the bigger or smaller the shadows appears. Moving forward, what is the relationship of shadowing and optical fiber? Shadowing in optical fiber refers to the attenuation that caused by various factors. There are two types of attenuation, which the first one is intrinsic fiber core attenuation, which is caused by the atom collision within the fiber, for example, absorption or scattering, and extrinsic fiber attenuation, which is caused by the outer or external force placed upon the fiber.
Next, we proceed to the conclusion part. As a summary, there are a few things that we can conclude from the presentation. Firstly, light allows us to see surroundings using our eye through the reflection of a non-luminous object. Secondly, the reflection occurs when the light encounters a boundary between different mediums, causing a portion of the light to be reflected back. Thirdly, refraction is the bending of light as it passes from one medium to another with a different refractive index. And lastly, shadowing, also known as the attenuation, refers to the decreasing in signal strength as light travels through the fiber optic cable. And that is all from my team for the topic of light properties regarding the reflection, refraction, and shadowing. Thank you.